There is a technique that, if you read in the textbooks, is called the change in oxidation number. And it is the method I am going to introduce you to. I'm going to introduce you to it because it is by far the easiest way to go about balancing redox reactions. Not only is it far faster, but it's far less likely to introduce you to mistakes. Unfortunately, most of the literature in freshman chemistry says don't do it this way. Do it by a much more complicated strategy, a mechanism. I don't even know the name of it, but it basically says take your redox reaction and go off and do a reduction piece and go off and do an oxidation piece, and when you're all done, add them all together and make sure it all works out. Not only does that take a huge amount of time and introduce an incredible amount of redundancy, but it doesn't guarantee that when you put them back together that you're not just going to make things a lot messier for a while. So I firmly suggest that if all you're wanting to do in this world is actually balance your chemical reaction, then go ahead and follow these steps here in this change in oxidation method. So what are the steps? The steps are pretty simple to see and understand up until the point where we see 4 and 5 pop up. But we can work our way through and watch this by working several examples. The first step is to assign the oxidation number. So I spent a whole lot of time teaching you about how to assign oxidation numbers. The second step is that I have to look at the oxidation and the reduction for each of the half reactions associated with the changing oxidation numbers. And the result of that will be that I can write down the number of electrons that change as I oxidize and reduce. The third step is to identify least common multiples for these two different half reactions and make them balance. Remember, I told you that if I've got electrons going this way and electrons going that way, when it's all said and done, they have to balance. So if I've got 2 electrons in this half reaction and 3 electrons in that half reaction, those aren't balanced. I've got to find some way of making them balance, and the easy way is by multiplying the bottom one by 3 and the top one by 2, so that I've got 6 electrons of transfer going in each direction. The final steps for balancing according to the oxidation number method is that if you happen to be balancing in a place where there's a bunch of oxygens and hydrogens running around, this probably means that you're balancing in either acid or base systems, which means I have to take into account the fact that I'm making protons and hydroxides that have to balance with the waters. So there's a nice, simple sort of process to do that. In acid, this is almost formulaic, but it makes sense. You add 1 water opposite the side which is deficient in oxygen, because you're adding an oxygen to balance the lost oxygen. And then you add double the number of protons to the other side to balance the fact that you're adding 2 hydrogens to this side that was balancing the deficient oxygen. If you're in base, then you add, and this does not seem to make quite as much sense until after you've carried the whole thing out, you add 2 hydroxides to the side which is opposite the deficient oxygen, and then 1 water to the other side for every 2 hydroxides. You see, you're adding that oxygen's water back to balance the oxygen that's here for the doubled hydroxide. So this may not make much sense as you do it, but it all cancels out when it's done. The beauty of these 5 steps here is that you do them without thinking. You systematically work your way through, and you do them without thinking. And when you're done and you look at this massive thing that you've balanced, and you do a mass balance and you do a charge balance, what do you know? It ends up working every time if you've done it correctly. After you've developed the rhythm for doing these redox reactions, it makes you think back to when you were in high school and how impossibly difficult it was, and realize, gee, why didn't they just teach me to do this right here? This works every time.